Madison.
Hi.
How are you, sweetheart?
I'm good. How are you?
Good.
That's my dogs.
Oh, well, you'll hear my dogs either barking or snoring, usually in math lab.
Oh, yeah.
I think my math puts them to sleep. Did you come for a specific question, or you just want to walk through the whole review with me?
Probably just walk through the whole review. I'm having a little trouble on this chapter, so.
Okay. Do you happen to have your graphing calculator with you? Yay! That is a very helpful tool for this chapter. I actually don't have mine out, which is kind of bad. But anyway, can you see the screen okay?
Yes.
All right. On this first one, sketch the graph of each function and compare it to the parent graph. On this very first one, the parent graph would be very difficult to draw on this particular piece because they kind of cut out the top part of the graph.
Yeah.
But it basically would look something like, oops, it would go through the origin and go up. That would be the parent graph. This particular one, just to kind of give you an idea, this negative 3x squared would tell us it's going to be a frowny face because of the negative, and it's going to be a lot skinnier. So to kind of give you an idea, I know 0, 0 is the vertex because it's not shifted anyway, because it's just one of those simple ones from 9.1, so there's no shift in the graph, either up or down. It's just only going to be skinnier. So if I plug in a -1, I'm actually going to get a -3 because -1 squared is 1 times a -3. That's -3. And if I plug in a 1, I'm going to get the same exact thing because 1 squared is 1 times -3 would make that -3. So I've got 2 points. And remember, we've talked about all we really need to graph a parabola is 3 points.
Yeah.
So if I do 1, -3, I'm going to go right there. And if I do -1, 3, I'm going to go about right there. So you can see it's a lot skinnier.
Yeah.
So for that, you could either draw, just like I said yesterday in class, you can either draw them, draw the graphs and make that comparison, because I would see that this is, you would just put this as y equals -3x squared. Or you could draw this graph right here and then just say it's skinnier and it's a frowny face, or reflected across the x-axis. I would take either one. Okay. I just want you all to know that if you're taking a test, an ACT or whatever, it's probably going to use those fancy math words, reflected across the x-axis.
Yep.
Okay, so for number 2, once again, the parent graph essentially looks like this. My graphs are not real pretty on here, Madison. I'm really sorry. And the other graph, I think I'll make it in green. It also goes through the origin because there's no shift at all up or down. And if I plug in a -1, that's going to give feedback a 2. And if I plug in a 1, it's going to feedback a 2.
Yeah.
So it's going to be skinnier too. But this one's a happy face. So you would just write skinny. So you would either draw the graph or write words to me. So skinnier, and it's a smiley face. But really, the only thing that's really different from the parent graph on this one is the fact that it's skinnier. Do those make sense to you?
Yes.
Okay. And also, don't forget, you can always use a graphing calculator. Are you comfortable with using the graphing calculator?
Yes, I am.
Okay, great. All right. This is something I did not get to tell your class. But I want you guys, because when I was working them out, I want you guys to omit this one, number 4. Because as I was working them out, it turns out to be a fraction on those. But you may have already gotten it. Did you already get it?
No.
Oh, you did? Bless your heart. What was the fraction?
No, I didn't get it.
Oh, okay. All right. All right. Well, good. Okay. The zeros of the function. Remember, those are just where it passes through the x-axis. So I'm going to go through a lot of steps just to make sure that you're understanding all of the concepts for this chapter.
Okay.
But I'm going to walk through a lot. All right. But really what you needed to do on this was sketch the graph and show where the zeros are. So you literally could have graphed these on your graphing calculator and shown me where they are. You see what I'm saying? Does that make sense?
Mm-hmm.
Okay. But the couple of things that I want to explain to you is that the whole reason that we went through like chapter 8 is that you could find the zeros of the function by just factoring this. So like what 2 factors multiply to give you 8 that add up to be 6?
4 and 2.
Perfect. So it would factor and look like that, wouldn't it?
Mm-hmm.
So that's going to be just 2. So now what you do is you set it each one of those equal to 0 and solve. One of my zeros is here for -4. Because basically what you're saying is, where does it cross the x-axis? So the 0 is really the y coordinate. And then the other one you would set equal to 0. And it's there. And then the next thing that I did was found my vertex. So that's the opposite of b, which in this case is 6, over 2 times a, which in this case is 1. So that's going to be -3 for my axis of symmetry and my x coordinate. For my vertex. And to find the y coordinate, I would plug in this -3 back in here. So -3 squared is 9, plus 6 times -3 is -18, plus 8. So then that turns out to be -9, because 9 plus -18 is -9, plus 8 is -1. So my vertex is -3, -1, which is right here. And now, how many points do I need to graph a parabola?
3.
3. Perfect. So I'm done.
Okay.
Or you could have plugged it into your graphing calculator. Is that what it looks like on the graphing calculator, or did you try?
That's what it looks like. Do you need to solve it manually on the quiz?
You would not need to give me the axis of symmetry nor the vertex if it just said sketch the graph and give me the zeros. You would have to tell me that the zeros are these, are -4 and -2.
Okay.
Because that's what it's asking for on this particular question. Okay?
Okay.
And the other way that it could be asked is, what are the solutions, or solve by graphing? It might actually say, if I'm remembering correctly, the answer to questions like this on the quiz say solve by graphing. Okay?
Okay.
So that's what the instruction is going to be like. That's what it's going to say right here. Okay? Solve by graphing. and I'm looking for the x-intercepts.
Okay.
So you'll have to sketch the graph and then give me the x-intercepts. So same concept that we're doing here, same exact concept. The only thing that I wanted to do, like I say, and I'm not trying to add confusion, I just wanted to give you a lot of experience of walking through the, the vertex and the axis of symmetry. Does that make sense? So that was the only reason that I did that, and kind of to show you that, that's another way to solve. Does that make sense? Like, you can use the graphing calculator, obviously, but since it only takes 3 points to graph a parabola, I can do that by, solving by getting the factors and by getting the vertex. Does that make sense?
Mm-hmm.
Okay. So can you think of 2 factors that multiply to give you a positive 15 that when you add them together give you a negative 8?
5 and 3, but it's a negative 8. So
Yes. So -5, -3.
okay.
Because a negative times a negative is a positive, right?
Okay. Yeah, right.
So x minus 5, x minus 3 are the factors. So if I set each one of those equal to 0, that's going to give me 5 and 3.
Mm-hmm.
Does that make sense?
Yeah.
Okay, any questions so far?
No, I see it.
Okay, so then I'll graph those points. And I could actually then find my vertex, or obviously you can use the graphing calculator. But just to give us a little extra practice on working out the vertex is the opposite of B, which in this case is -8, over 2 times A, which in this case is 1. So that's going to be -4. And if I plug in -4 back up here, -4 squared is 16 times a -8.
16 times a negative 8.
Oh, wait, this is actually a +4. My bad. Because the opposite of the opposite of -8 is +8. I'm sorry. Divided by 2 is a +4. So I'm plugging in 4 squared is 16 minus 32, because +4 and -8 is -32. So that plus 15. So that would give me -16 plus 15. That's a -1.
So that's a negative 32, so it'd be negative 33. Right?
I'm sorry?
That's a negative 32, and then negative 32 plus a -1 would be negative 33, right?
Well, 16 minus 32 is -16.
Right.
Love you. Drive careful. -16 plus 15 is -1. Does that make sense?
Yeah.
Okay. So my vertex is this. So I have my 3 points because I've got my x-intercepts and I've got my vertex. And so that's what my graph looks like. But basically for this, if I was solving by graphing, the most important thing is this part over here.
Okay.
Okay? That's the most important part. That's what I'm looking for when I say solve by graphing. So if you plugged in x squared plus 6x plus 5, I'm going to pull up Desmos. I may need you to remind me of that fraction, if you don't, or that equation, I'm sorry. Can you see it okay? Y equals, can you see Desmos?
Yes.
X squared plus 6x
Plus 5.
plus 5. So the solving by graphing, my answers are -5 -1.
Mm-hmm.
So that's what I'm looking for. And then down here, that's my vertex.
Okay.
Isn't Desmos wonderful?
It is.
So I got -5, -1. And what was my vertex again? What was it, 4, 3? That looks about right, though, because if you think about it, it has to be symmetrical, those. So what you're looking for is what point is exactly in the middle of those two. Does that make sense? Because everything's symmetrical on a parabola.
Yeah.
So that was another way of solving by graphing, just pulling it up and being able to look at it. But I want to show you one other thing. What two factors multiply to give you 5 when you add them give you 6? It's going to be x plus 5 and x plus 1. So if I solve those, I'm going to get my x-intercepts. Does that make sense?
Yeah.
Is it a little clearer now?
Yeah.
Or not really?
No, it's clear.
Okay, good. I did a lot of extra things that you might not have needed to do on this because basically I just needed you to graph it and show me the x-intercepts. But I did some work with the vertex and the axis of symmetry just because I wanted to keep giving you practice in those. Okay?
Okay.
Now, more fun. All right, on this one, all right, any questions on part 1?
No.
Okay. On this part, identify the vertex and the axis of symmetry, and then sketch the graph. On this particular one, the vertex is going to be 0, 1. Do you understand why?
Mm-hmm.
Okay. And the axis of symmetry is x equals 0, which is the y-axis. Now, is this going to be a frowny face or a smiley face?
Brownie face.
That's right. And once again, you can plug this into your graphing calculator if you want to. But this one was pretty simple. So over I'm sorry, that's a -2 over 1 because basically when you square that -1, it's looking for the opposite.
Mm-hmm.
Actually, that's going to be opposite of 1. That's going to be 0. My bad.
Hello?
I'm there. Sorry about that. I was doing something with my dog. Sorry.
It's okay.
There we go. Struggling drawing too. All right, so the vertex and the axis of symmetry for number 2 would take. Are you feeling pretty confident about the -b over 2a?
Yes.
Okay, good. Okay, so the opposite of B over 2 times A. So that's going to be -5. So my axis of symmetry is -5. X equals -5. And then to find the vertex, I'm going to plug in that -5 back into the equation. So -5 squared is 25 plus 10 times -5 is
-5.
and then plus 21. So 25 plus a -50 is -25 plus 21 is -4. So my vertex is -5, -4. So it's right there. And then you sketch the graph. And you can do this one of two ways. What I've been doing to kind of continue to give myself practice about the x-intercepts, and this will only work really when you can, number one, I know the axis of symmetry is below the x-axis here. You know, it's kind of below that. Does that make sense to you when I'm saying that?
Yeah.
Or the vertex is below that line. So I'm pretty sure this is going to go through the x-axis somewhere because the vertex is below the x-axis. So I could actually factor this and find my x-intercepts, which would be my other 2 points. Or you can use your graphing calculator. But I know that the two factors that multiply to give me 21 and add to give me 10 are 7 and 3. So x plus 7 and x plus 3 are those factors because 7 plus 3 is 10 and 7 times 3 is 21. So I know that my intercepts, my x-intercepts or my zeros or the solution to this graph are going to be the opposite of those, which is -7, because if I plug them into the little mini algebra problems, I would get the opposite. Does that make sense?
Mm-hmm.
If it doesn't, just stop me. But then, huh?
Why do we have to do the x plus 7 and x plus 3 for this problem?
You don't necessarily have to. You can use your graphing calculator and you can copy the graph if you want to. I'm just telling you that, you know how it takes 3 points to graph a parabola?
Mm-hmm.
You could either do an x and y table like we did over here on this problem, and you could do an x and y table for this one also. You could plug in that -4 and -5 and find a couple of other points. Mm-hmm. But I know that since this vertex right here fell below the x-axis, there's a good chance that it's easily factorable and that I could find my other 2 points by doing that. Does that make sense? I'm just looking for 2 more points in all of the different ways that I can. I can do a table of values, or I can find the x-intercepts.
Okay.
Does that make sense?
Yeah.
What would you prefer to do? Just plug it in your graphing calculator?
Yeah.
Okay. All right. Well, that's fine. You can certainly do that. Are you comfortable with finding the vertex and the axis of symmetry?
Mm-hmm.
Okay. Number one, I just always like to practice as much as I possibly can, when I can, of finding those x-intercepts, because that's a lot of times what you need to do. But we'll do number 3 and number 4. We'll just plug those into the calculator after we get our vertex. Does that sound good?
Yeah.
Okay. I'll use Desmos on here if that's okay with you. That way you can see what I'm doing. Okay?
Okay.
All right, so the vertex, once again, we're using negative b over 2a. So the opposite of negative 6 over 2 times negative 1. Do you see where I got all those numbers?
Mm-hmm.
Okay, so 6, because the opposite of negative 6 is positive 6. And then 2 times a negative 1 is negative 2. So the axis of symmetry and the x-coordinate for this graph is x equals negative 3.
Okay.
Now, to find the y value. So we've got the opposite of negative 3 squared, which is negative 9. Does that make sense where I got that?
Mm-hmm.
Okay. And then minus, or a minus 6 times a minus 3 is going to be plus 18 minus 10. So I have negative 9 plus 18 gives me a 9 minus 10, which is negative 1. So my vertex is negative 3, negative 1. So right there. And now I'll go over here to Desmos. Negative x squared minus 6x plus 10. Huh. I did my math completely wrong, didn't I? Did you get it right?
Actually, it said error when I put it in. Okay.
Oh, you know what? I know what I did wrong. It's minus. My bad. That helps. Plugging in the equation correctly helps.
I have negative x squared minus 6x minus 10. That's the right equation, right?
Yeah, I accidentally, the first time I typed it into Desmos, I put plus 10.
Oh.
So it's negative 3, negative 1 is the vertex, and then then the graph looks like that. So
My thingy says error.
you know what? Did you when you plugged in the minus x squared, did you hit the little parenthesis minus, or did you hit a minus minus?
I hit a minus.
Okay, you have in the front of the negative x squared, do you see the little parenthesis button at the bottom with a minus in it?
Oh, yeah.
That's the one that you need to use for a leading negative.
Okay.
The minus is fine for the one in front of the negative, the minus 6x and the minus 10. But when you're leading, when the leading coefficient is a negative, that's the button you need to use.
Okay.
So do you know how to delete and reinsert and all that stuff?
Mm-hmm.
Okay. Did you fix it?
Yeah, I got it now.
Okay, cool. The first time I did this particular problem, I did a table of values just so that, and I plugged in my negative 3, negative 1 for my vertex. But this way I had some concrete values. And it was negative 1, negative 5 over here. So I knew I went 2 this way, so I could go 2 this way. And that's how I sketched it the first time I did it.
Oh, my computer's about to die. I'm gonna plug it in real quick.
Okay.
Sorry.
Oh, no, you're fine. You're fine.
Okay.
So I guess the reason why I went ahead and showed the table of values on this is I'm trying to show all of the different ways that you can find if you don't have a graphing calculator, which it's a blessing to have that, obviously. But if you don't have a graphing calculator, I wanted to go ahead and show the table of values to get 2 more points, because we only need 3 points. So I can either factor like I did on number 2, I can do a table of values like I did on number 3, or obviously you can use your graphing calculator. But, you do have to make sure you write down your vertex and your axis of symmetry.
Got it.
And tomorrow, because I'm saying it's okay to use Desmos in your graphing calculator, for the ones where you have to find the vertex and the axis of symmetry, I want everybody to show their work, to show me how you're getting the negative b over 2a and stuff like that.
Okay.
You're usually really good about showing your work, though, so that's not an issue for you. For number 4, let's see. Where for the vertex, the opposite of b is -6. I'm going to erase some of this stuff right here. I really got in the way of myself.
Wouldn't it be a -3 again?
Oh, it looks like it. Let's see. Times, it might be a positive, because you've got that 2 times -1. So that's going to be a -6 over -2, which is a +3.
Yeah.
But you got the 3 right. So, yeah, there's a lot of negatives and positives going on in this thing. So, 3, and then we plug in. So, the axis of symmetry is 3. And then we plug in that 3 back in. Does that make sense where I got my 3? Negative, okay. And then plug that 3 back in. So you get the opposite of 3 squared, which is 9, plus 18, because 6 times 3 is 18, minus 8. So that's going to be 9 minus 8 is 1. So it's the exact opposite of the last one that we got. And it's going to be a frowny face. So we're going to go over 3, up 1. So there's our vertex. And then we can do a table of values, or we can go over to good old Desmos. And this time, Miss Sparks will try to type in the problem right. Tell me if I do it wrong. Can you see it? Okay, good.
I think you did it right.
Yay. And then, oh, look, we have 2 x-intercepts on this one that are pretty easy to find, too. So that's cool. 2 and 4. So there's the graph. So we have a axis of symmetry of x equals 3 and a vertex of 3, 1. All right, on this one, the opposite of -4 over 2 times a -1. So the opposite of -4 is +4 over -2, which would give us a -2. And then when you plug in that -2 back into the equation, you've got the opposite of -2 squared, which is 4. And then a -4 times a -2 is a +8 minus 10. So we have -4 plus 8, so that's going to give us 4, minus 10 is -6. Is that what you got?
Yep.
So we have an axis of symmetry of x equals -2 and a vertex of -2, -6. And it looks like it's going to go upside down. So let's go over here to Desmos. Is it -4x?
Yes.
Is it +8?
No, it's
What?
-10.
-10?
Mhm.
I was totally wrong. Okay. That's weird. It barely shows on the graph.
It's kind of hard to graph.
It is hard to graph. That's because the y-intercept is way down here at -10, which means there'd be another one over here. It was a weird one to graph. They didn't give us a very good cut of a graph on that one, did they?
Didn't.
And then the last one. So the opposite of b, so the opposite of -2 all over 2 times 1. So that's going to be 2 over 2, which equals 1. So my axis of symmetry
It's 1.
is 1. And then I'll plug that 1 back in. 1 squared is 1. Minus 2 times 1 is 2. Minus 2. So 1, and then 1 minus 2 is -1, and -1 minus 2 is -3. So it's 1, -3. That's symmetry. So we'll go over here to Desmos, because I'm assuming you're using your graphing calculator, right?
Uh-huh.
Okay. So it's x squared minus 2x minus 2. Is that correct?
Yes.
Okay. So we've got a y intercept of -2, and then we've got some big time fractions on the x-axis.
There we go.
And I don't think, oh, something else I want to tell you, Madison, while we're here, because I want you to get the bonus, particularly because you came to Math Lab. Tomorrow, the bonus is going to be about the minimum and the maximum. Okay? And what you need to know about that is if it's a frowny face, it's a maximum because you can't go any higher. And I think you got this right in class. Okay, because you can't go any higher. So like on this one, on number 4, that would be a maximum point. So it's going to ask you, does this graph have a minimum or a maximum? And that will be for 2 points. You'll answer that question. So down here, this one has a minimum, right? Because you can't go any lower than that. Then the second part is going to ask you, what is the value of that minimum or maximum? Okay? And all that is the y-coordinate of the vertex. The value is. So the x-coordinate is the axis of symmetry, and the y coordinate of the vertex is the minimum or maximum value. So on number 4, the maximum value is 1. On number 6, the minimum value is -3.
So you would solve it and get the y coordinate?
Well, yeah, and you've already got it if you've done the vertex. And what I'm going to do is ask it on one that you've already gotten the vertex on.
Oh, okay.
You see what I'm saying?
Mm-hmm.
So just to kind of quiz you on it, not to put you on the spot or anything, on number 3, right here, this one, does it have a minimum or maximum?
A maximum.
Good job. It has a max. And what would the value be?
-1.
Perfect. You've got it. And just to be double sure, on number 5, does it have a minimum or a max?
Max.
Good job. And what would the value be?
Where? I can't see the point. -6.
-6. Perfect. So that's going to be the bonus tomorrow.
Thank you.
Hey, no problem. And it's worth 5 points.
Ooh.
Yeah. The other thing is there's only 8 problems on the whole quiz. But that's because, it takes a little more time to do, the vertex and the axis of symmetry and plug in all this stuff in your calculator.
Yeah.
So, but that's what that now you've got the bonus and everything. So just to be double sure that you're going to understand everything, tomorrow, right here on this problem here,
Number 3.
on these, on 3 through 6, on the original, on part 1 of the review, that is going to be asked in the way of by graphing.
Okay.
And you're looking for the x-intercepts. Okay?
Okay.
The other question that's on it is it's going to ask you for the zeros of the function. And there's no graph.
Okay.
Okay? So you would be finding the x-intercepts, okay, or factoring. Does that make sense? Good old factoring. You remember how to do it. You rocked factoring. You did so good on that.
Thank you. So the x-intercepts wouldn't be the y-intercepts. It would just be the x, right?
Yes, ma'am.
Okay.
No, you don't find the y. The y-intercept on these are pretty easy because it's always just the constant at the very end. Because if you plug in a 0 for x, you just left with the constant.
Yeah.
So it's pretty easy. But no, it's just the x. So, and you find the x-intercepts by factoring.
Okay. Oh, right. Yeah.
You find the x-intercepts by doing that, or you can graph it, and where it crosses the x-axis, So you can either plug it in your calculator and try and figure out what they are, or you can factor it quickly.
Okay.
Okay?
Okay.
I can't think of anything else about the quiz. How do you feel better than you did when we began Math Lab?
Yes, I feel so much better. Thank you so much.
Oh, no problem. Praise the Lord. Thank you so much for coming.
Thank you.
I got to see you twice this week already.
Yep.
You have a blessed day.
You too.
Bye-bye.
Bye.